Hello, my name is Karen, and I'm going to give you a quick guide to our unparametric nitric oxide microsensor. This guide will focus on the most important measuring characteristics of the nitric oxide sensor. If you would like in-depth information and detail about Unisense nitric oxide sensors, please see the lecture about Unisense unparametric microsensor. This is a schematic drawing of a nitric oxide sensor. It consists of a tapered glass casing, a silicone membrane, a carbon working electrode, and a reference electrode. The signal from the nitric oxide microsensor relies on oxidation of nitric oxide on a carbon working electrode. Nitric oxide diffuses through the tip membrane to the working electrode, where it is oxidized on the positively polarized working electrode. The electrons for oxidizing nitric oxide are supplied from the reference electrode. All of these electrodes are soaked in an electrolyte for balancing charges. This generated current can be related to the nitric oxide partial pressure. It is a very small current that is generated, and we only guarantee the performance of our nitric oxide sensors when used with a Unisense amplifier. Detailed specifications are available on our webpage. I will, however, elaborate on a few of the most important sensor specifications. Unisense microsensors are handmade, and our skilled technicians can customize sensors to obtain the best possible characteristics and design to your specific application. The model name indicates the sensor type and tip size. Hence, a NO50 is a nitric oxide sensor with a 50 micrometer tip. We can produce them with standard tip diameters from 15 to 500 micrometers. Besides the tip size, we can customize the design of the tip to be more or less slender, as well as the body length and shape. Please consult our tip selection guide to get more information about choosing the right tip size for your application. The sensitivity of the sensor is strongly influenced by the experimental setup. We have made these sensors as sensitive as possible because nitric oxide is typically found in very small concentrations. Therefore, the sensitivity given here is the best possible we can achieve, and the model with the larger tips had the lowest detection limit. The smallest model with 15 micrometer tip has a detection limit of about 25 nanomolar, whereas the larger tip sizes have detection limits in a few nanomolar range. A nitric oxide microsensor responds very fast to changes in nitric oxide partial pressure. The smaller standard sensors have a response time less than a second, whereas the larger models have a response time less than 10 seconds. We can modify and adapt our nitric oxide sensors, making them useful for a broad range of applications. We can build the sensors into needles to protect the glass sensors, which also makes it possible to pierce different membranes with the sensor. With a protection cap, the sensor can be safely used for bulk measurements in larger samples. For our micro-respiration system, the sensor is equipped with this special guide, and it has a long, slender tip. This tip can be inserted into the small chambers without contaminating the small samples. The sensor body can also be made of steel with threads, so it can be screwed into pipe systems or incubators. The sensors can also be mounted in different gas-tight flow cells. We have this transparent glass flow cell and these pressure-tolerant swage-locked steel flow cells and peak flow cells. In general, if you have any specific requests regarding sensor adaptations, please do not hesitate to contact us. We would be happy to discuss your application and find a suitable solution. Thank you for watching this Unisense microsensor lecture. I hope you enjoyed it. If you have any questions, you are more than welcome to contact us at sales@unisense.com.